Okay, we're now going to do the normal distribution backwards. We're going to do these problems, kind of like the probability problems for any normal distribution. We're going to reverse it and go backwards, just like we did for the z-scores. And in fact, what this involves is finding the z-score just like we did before, and then converting that z-score back into the x-score. So really, this isn't any different than what we did in the previous, when we were doing just z-scores. We're just adding one more step where we're using the reverse z-score formula to take the z-score we find and then convert it back into the x-score. So I'll do one of each kind. There's kind of those three cases. And so this one says, below what weight is the bottom 38% of the products? So I guess I should read this. The weight of products is normally distributed with a mean of 13.47 and a standard deviation of 0.47. Okay? And so below what weight is the bottom 3.8% of the products? So I like to draw a distribution here, and I'll put the mean 13.47 and the standard deviation here is 0.47, and this kind of represents the distribution of all the products. These are like products made by a company, maybe they're bags of chips or whatever, and the bags kind of vary a little bit, and they have a normal distribution with a mean of 13.47, standard deviation of 0.74. Okay, so the bottom 3.8% would be these bags over here that are the lightest bags. So this little bit over here, okay, where this percentage here is like 3.8%, and what we want is the weight here. The weight, something below 13.47 ounces. That's going to give me kind of that cutoff that separates the bottom 3.8% from all the ones above it. So what I'm going to do is I'm going to find the z-score just like I did before. What z-score has 3.8% below it? Okay, so I'm going to convert this to a 4-digit decimal number. And then I'm going to use my normal table backwards. Now I gotta find my normal table. Where is my normal table? Ah, there it is. Okay. So I'm looking for 0.0380 on the negative side and find what comes closest to that. 0.038. 0.03. Here's 0.0384 and then 0.0375. So it looks like this 0.0384 comes closest. And that corresponds to negative 1.77. So this z-score is negative 1.77. So that's the z-score that gives me the bottom 3.8%. And really, that's no different than what we did before. So now all I got to do is I got to convert this z-score back into the x-score. And to do that, I'm going to use that reverse z-score formula from the previous video. So I'm going to take the mean, and then I'm going to subtract 1.77. So since it's a negative z-score, I just do the subtract and then write just the number of the z-score down, and then times the standard deviation. So 13.47 minus this z-score times the standard deviation. So 13.47 minus 1.77 times 0.47. And so we get this weight here, and what I would do is I would round these to the same number of decimal places as the the mean and standard deviation that you're using. So it kind of matches those. So that would be 12.64 pounds. And so that would be the answer for that. So 12.64 pounds has the bottom 3.8% of the areas. Okay, well, what about this one? This is above what weight is the top 13.8%? Okay, so you're going to draw the distribution like before. And you have the mean and the standard deviation. And then the 13.8%, it's going to be up above here because you want the top 13.8%. And this is going to have more area than this one over here, right? So this is going to be, the z-score that we want is going to be a positive z-score, okay? And it's going to be the z-score that has this area above it. So if you remember, this is like the case 2, kind of like a greater than probability. So we got to subtract from 1 first. So I'll change it to the 4-digit decimal number. Okay, and I'm not going to look that up because I want the z-score here that doesn't give me this. I want the z-score that gives me the area down here. And the reason is the table gives me this area, right? So I got to look up that area. So I take 1 minus 0.1380. So 1 minus 0.1380. And so this is like 0.8620. So what I'm doing is I'm looking for the z-score that has that area below it. I'm going to look this up on my table. So 0.0826. I'm going to look on the positive side. So 0.8620. 0.8621. So that comes closest, and it is 1.09. So this is 1.09. So that's the z-score, and that's no different like what we did before. Now once I have that, I got to convert the z-score back into the actual weight of the product. So 13.47. In this case, that's a positive z-score, so I'm going to add the z-score times the standard deviation. And that's going to give me 13.47 plus 1.09 times 0.47. That's, I'm going to round that to 2 decimal places there, and that's what this is up here, 13.98 pounds. So what product has 13.8%, or what weight has 13.8% of the products above it? It'd be 13.98 pounds. Okay. So I could have wrote this down here. Okay, so those are like, this is kind of like the less than probability, greater than probability, and then of course we have the between probability. But when we do it backwards, it's always between what two weights is the middle, in this case 93% of the product. Oop, there we go. So between what two weights is the middle 93% of the product. So I'll draw my distribution, use the same values. So the mean is 13.47, standard deviation is 0.74, and then 93%, that's a lot, most of the products, isn't it? So something way out there. And this is like the middle, we'll say middle 93% of the product. Okay, and I want the two weights that have that middle 93%. So I'm going to need these two z-scores. One is like the negative one, one's the positive one. Okay, so the way that we do this is we find these areas in the tails. And so we do that by doing 100% minus 93%. That gives you 7%. So if you want 93% in the middle, you want 7% on the outside. But that has to be divided evenly between the two tails. So that's like 3.5%. So this is 3.5% up here. This down here is 3.5%. So those three add up to 100%. So now I'm going to convert this to a 4-digit decimal number, and that's what I want to look up to get the negative z-score. So 0.0350, and it looks like I got it right here, 0.0351. So that's negative 1.81. So this is negative 1.81, and this over here is the positive 1.81. So then I got to convert both of these up into their actual weights. I got the two z-scores, and getting those, that's just like what we did before, but now I use the reverse z-score formula to convert them back into their weights. So this would be 13.47 minus 1.81 times 0.47, and this would be 13.47 plus 1.81 times 0.47. So you can see that the 1.81 times 4.47, that's actually giving you this distance, and this one down here subtracts that distance. This one up here adds the distance. Okay, so I'll do 13.47 minus 1.81 times 0.47, and I get, and I'm going to round to 2 decimal places, so 12.62, and then this one is the plus here, so I'm going to just go up and edit and change that to a plus, and I get 14.32, and so that's these here, 12.62, 14.32. So it's between these two weights that you get the middle 93% of the products. So that is doing the normal distribution backwards. I think maybe I'll have one more video that gives you another example, and it's going to involve finding like grades for when someone like grades on a curve. So kind of a neat example. And it also helps you understand what it really means to grade on a curve, as we will see.